Hey code bombers, what's up? It's your favorite code bomber, Vivs here from Slide Nerd. In this video, I'm going to talk about the Job Scheduler API. If you're looking at this video for an example, I'm sorry, it's there in the next video. Here, I'll simply introduce you to the API and talk about the old way versus the new way of doing things, plus an introduction, a visual introduction to the API. So let's get started. Fetch the list of the latest movies from Rotten Tomatoes API every 24 hours or every 1 hour. How did we do that so far? We had Alarm Manager plus intent service, or we used to have the sync adapter. Let's talk about the disadvantage of the Alarm Manager plus intent service. Here, the Alarm Manager has no idea what is happening with the device. Is the device getting charged? Is it running low on battery? Is the user going to incur additional charges on the network if they download now? Is the device going to reboot? What happens when we reboot? All these things were not considered by your alarm manager plus intent service. Now if you remember, while using the intent service, we had to write a broadcast receiver with the action boot completed to start things up once again when the device rebooted. And if you talk about the sync adapter, that is no less, it has a lot of puzzles. It's pretty tricky to use. It's buggy. It has a lot of errors. There's not much documentation available on the sync adapter as to what you can do with it. And the worst thing of all, it's definitely not the best option for doing periodic things in the background. And that's where the Job Scheduler API comes into the picture. Job Scheduler is what Android and Google calls intelligent background processing. You can batch more than one job when resources are available. Now, the jobs don't necessarily need user interaction, and in fact, you should ensure that you don't replace the async task with a job scheduler just because it's new. Because you need to see whether the user is going to interact with it or not. There is user upload and user download data from the background, like database migrations online to your server. All these kind of things can be done with a job scheduler. And the best part is several jobs can be combined together so that the battery impact is minimal. So let's take a look at what kind of stuff can happen with a job scheduler. When to use it? Well, first of all, the task you want to run should require the battery supply. That is a nice case for it. Or you want to ensure that you run the background task when there is network or Wi-Fi access. Or otherwise, the user does not interact with the task on a background job and you want to run your job scheduler. And the most important part, you want to run something again and again every 20 minutes, and timing is not that critical. So there are certain constraints that you can specify with the job scheduler API. There are simple and complex constraints. Now let's take a look at the simple constraints. You want to run a job only when the device is charging. You want to run a job only when the user is running a network which is not going to incur charges on the user if you use that network. The device is idle. Or you want to start, say, before 1 hour, or say you want to start within the next 2 hours, or you want to wait for 10 minutes and then start a job. All these kind of things can be specified as simple constraints. So what are complex constraints? Let's take a look at that. You can combine all the constraints together to say something like this: schedule a job every 20 minutes when the device is connected to an unmetered network and when Wi-Fi is available, something like that. So that would make a complex constraint. So you can specify these constraints and you can make your job scheduler really smart about how you want to process background tasks. Let's get a visual look on how the job scheduler API is supposed to be used in your app. First, define the constraints that you want with the help of the job info.builder class. Now use the build method on this class to create a job info object that contains all your constraints. Then define a class that extends job service. Inside the onStart job method, you will define the work that you want to do. It runs on the main thread by default. If you want to do it on the background thread, create an async task over here. Then once you're done with the task, call job finished to indicate whether you want to reschedule the task again or you consider that the job is actually finished. And then there's the onStop job method that gets finally called, indicating that your job execution is complete and you want to do something with it. And this is the whole code that goes inside your job service. Now the most important part is your job scheduler class, where you call the schedule method and you pass the job info object containing the constraints that you specified. In other words, once you say job scheduler.schedule, the job service is going to be triggered every time the constraints or the criteria is met, and your code is going to be executed inside the onStart job method where your background task is going to be performed. And last but not the least, this would be the impact on your battery performance. The job scheduler will automatically consider the several jobs that exist out there and try as much as possible to schedule them in such a way that the impact on the battery is minimal. So now I have shown you what the Job Scheduler API looks like and how it works from a higher level. In the next video, I will dig into our app that we have been building so far and add a job service to download data from Rotten Tomatoes API every 24 hours or so. In the meantime, if you like what you saw, please like this video, share this video, subscribe to Slide Nerd, and let us know your thoughts in the comment boxes below. Thanks for watching. I'll catch you guys in the next video. Have a nice